All right, thanks everyone for joining me today. Really appreciate it, everyone for taking the time out for this presentation. This presentation is going to be about as-built surveying best practices by Precision Property Measurements. Let's go to the next slide. My name is Michael Lee. Everyone at the office calls me Lee. I'm the regional director for our Northern California office here at PPM. I've been with PPM for I think 8 years now, about 8 years. Um, let's see. When I started, I was actually hired as a surveyor, so the person on site doing the as-built measurements for you, and this is before we used our LiDAR scanners that I'll get into. So I was on site with the disto, huge clipboard, pen and paper, lots of pens, lots of paper, tape measure, crawling around a house, taking all the measurements necessary to get you as-built needed. And here's a picture of me from 8 years ago. You can see a lot has changed. Hairline's starting to go back, losing a bit of got that LASIK in, so that's good to see at least. All right, just jumping in. I'm not going to read all of this for you, but just kind of letting you know the credits for this taking this course with me today. Course description. So objectives are I want to kind of talk about, recognizing when and how to use terrestrial laser scanners to gather field measurements, knowing when and how to employ mobile scanners to take field measurements, understanding the role that point clouds play in displaying data in a usable form, and be familiar with techniques for drafting and modeling as-built scope items in AutoCAD, Revit, and BIM software. I won't read all that huge paragraph for you right there. There's a lot of slides to go through. And then I do want to say, if anyone has any questions, please feel free to shout out. We can wait until the very end, but because of how many slides there are, I don't want to forget any important questions you have. So today I'm going to be talking about we're going to be doing we'll cover three major areas here: laser scanning, point clouds, and building information modeling (BIM). So that's going to be Revit, ArchiCAD, SketchUp. Um, Throughout the presentation, I'm going to ask a series of polls, which will ask multiple choice questions. Yeah, so just moving on. Poll number one is, please shout out, I guess, or type your answers in the chat. How do you guys currently obtain your as-built plans? A, you create them yourself. B, you have an internal team create them. Or C, you partner with an as-built firm. Again, please feel free to just type your answers in the chats there. And for anyone that put A, uh, side question is, do you enjoy doing it? Because it's a long, arduous process from when I used to do this myself. So let's get started with section one, laser scanning. So updating or even replacing a proven method of doing something by utilizing the newest technology. It's not really the newest technology anymore. It's been around for more than a few years now, but it's not easy no matter what industry you're in. First step you take is the most important, and the rest is hard work and diligence. Even though it may be difficult to transition, um, it makes the change to laser scanning as a survey method. Um, Making the change to laser scanning as a survey method provides you with fast data acquisition, more accurate. It's more accurate than any measurements that can be taken on hand, reduces the odds of human error dramatically in the field. And an example of that is when you're taking measurements using a tape measure or disto, you have a little typo writing that down. That when you're then drafting or creating the BIM model can throw your entire model way off, and it requires a lot more troubleshooting. What we use for 3D laser scanning creates literally millions of points. So if one point is wrong, the other 999,000 plus will be correct. This tech can now be purchased, rented, or contracted. It's a thorough solution. It allows surveyors to gather more data than needed to complete most projects, like I mentioned. A lot of it seems like overkill, but it does help the production process later on, And then what it could do is provide a digital twin to pull additional data from down the line if the projects ever need to be revisited or additions need to be made to the scope of work. We get that questions from clients all the time of what that looks like. So for example, if we have a 3D model of your home scanned with a laser scanner and down the road someone needs sections pulled or additional ceiling information, chances are we have that. So it's helpful without needing to make repeat visits to a client's home. So what does LiDAR mean? We hear about it in the news and in various articles about autonomous vehicles and robots. It's the same technology. My vacuum is LiDAR based. So it maps out the room and it vacuums up based on the map that it generates. Not the same level of accuracy, but yeah. It stems from the word radar, which stands for radio detection and ranging, much older tech, but it works in the same way. Light detection and ranging. So it's measuring the time and for light to be reflected back and then using that algorithm to create a point cloud for you. Each single measurement is logged, and throughout the course of the scan, millions of measurements are taken in all directions to maximize accuracy. So let's talk about LiDAR scanners that we currently use for architecture, engineering, and construction. Um, so the first one is going to be that really heavy duty terrestrial scanner that we use. When we need very, very accurate measurements or a lot of intricate detail captured for historical projects, our team in DC does those a lot. Structural or engineering analysis or prefabrication projects, we go with our favorite terrestrial scanner, the Leica RTC 360. And that's a shot of our very own Colin Lenkite. Fun fact about him is he's been with PPM, I think, as long as some of our youngest colleagues have been alive. So about 20 plus years at this point. Doesn't look a day over, I don't know how old Colin is. So here it is scanning the some features about it. It's stationary. It's used on a tripod stand. It shoots about 2 million points per second. And what it does is you kind of move that tripod, set it down, run away, hide from it, or stand behind it as it rotates. Extremely accurate within 1.9 millimeter accuracy up to, I'm not sure the exact distance, but pretty far. It does colorized point cloud and it does black and white. Colorized does take a little bit longer because it needs essentially two spins, one for LiDAR and one for color and photographic based scanning. We really use these for larger commercial buildings, hotels, especially offices, anything where access is going to be limited or a higher level of detail is needed. So we do these a lot for hotels in San Francisco, a lot of the older hotels with really ornate details that they want us to capture. And then again, scan time, like I mentioned below earlier, was it varies based on resolution and color settings. The scanner costs around 80 grand. Software is included. We do have a fleet of these that we fly around the country, depending on need and when we get these larger projects that require it. All right. And here it is scanning the hotel. I think it's at LA. Let me go ahead and play the video for you real quick. So this is actually that point cloud that I'm talking about. It's all, LiDAR based, light based. Um, so while the other scanners can be moved while operating, the RTC needs to be placed in multiple positions all over the building to get a full set of measurements for our plans. Each red dot that you see here is a place where we placed the actual scanner to gather the black and white data that you see. Even though we didn't use the camera for this data, it looks, I would say it's, the level of detail makes it look like it's photographed. You can count the individual the bricks on the wall there. So that's what we mean by high level of accuracy in data. Each black and white point or pixel is representative of an actual laser measurement, accurate down to less than 2 millimeters. that means the entire 3D picture you're looking at is dimensioned accurately. For this particular project, we use this data to help an architect identify floor sagging, wall sagging, and other structural issues before major remodel of this 100-plus-year-old casino. Looks like in Colorado. So actually, let me just scroll back at the beginning there. So you could see from that point cloud, you can see that sagging on the walls for Easy Street Casino, and the LiDAR scanner is able to capture that very accurately. And then for reference, here is a final result of a project scanned by the RTC 360. It's the Olympia Hotel at Capitol Lake in Washington. Um, and then let me play the video for you guys. Here's the same property where our team overlaid that point cloud into the Revit model. So as we do a live section and cut it down, you could see that level of accuracy as we move that scanner. A couple of things I want to point out that is not part of the presentation, but if you notice on the roof, there's a lot of areas that are white, especially around the center area. I'm not sure if you guys can see my cursor. Um, because of how much data the scanner gets and how far it can shoot, we don't necessarily need to get full coverage. Because it's just looks like a single pitch roof, putting the scanner off to the side is able to get a good majority of the roof and what we need for as builts without climbing up and measuring every square inch of that roof and space. So we talked about terrestrial scanners. Like I said, it's more for heavy duty stuff, bigger detail, larger scoped areas. So now I'll kind of talk about our more commonly used mobile scanners, the ZEB Horizon, made by Faro, formerly no, it was formerly made by GeoSlam. GeoSlam got bought by Faro about a year or two ago, if you guys are aware. So the Faro ZEB Horizon, and then the BLK to Go, made by Leica. Um, some general points about mobile scanning and processing. So using a mobile scanner is preferred if you need accuracy and your time on site is limited. So most individual scans for a single residential house takes about 15 to 45 minutes only. We recommend you process the scans on site to check your results before you leave. Once the scan is completed, you need to use all the SLAM algorithm on site to actually process the scan. And it interprets the measurements and movement data from the scanner to produce a 3D point cloud that you see here. Um, After the SLAM algorithm takes place, it produces a 3D point cloud. You then need to review the point cloud to ensure accuracy. So this is just that very, very first step. Most errors in scanning or processing can be spotted fairly quickly, such as warped walls or overlapping rooms. There's going to be a variety of things that can cause bad scans. Um, and then if that happens, actions such as rescanning should be taken to ensure overall accuracy of your project when the time comes to draft or model. Um, and then we'll kind of we'll touch on these potential point cloud errors a little bit later as well. I know I'm flying through this. If anyone has any questions, again, please feel free to shout out. So this is what a point cloud data looks like in plan view. We're looking at it top down. You can see that even though there is no photo-based colorization in this point cloud, what we use here is a height ramp where points at different heights are shown at different colors on a spectrum. Where you can see on the left, I think it's lower, and then blue is higher. So you can see that there's going to be some two-story, there's a second story to this building based on that blue section right there. Coloring the point cloud this way makes it easier to see important features in the point cloud, even without the photo colorization. All right, that's the true star of our show. That's Rogi. He's been with PPM for about 10 years as well, and serving the entire time while doing so. Um, And then here's the other scanner that we use, the BLK to go. It's made by a different company. It has, it can handle different kinds of properties. We primarily use them for single family residences, restaurants, retails, and smaller commercial spaces. I do want to emphasize smaller just because it doesn't shoot as far. It doesn't mean it's any less accurate, but when you're when you're inside a large industrial space, because it doesn't shoot as far, that data from the far side of that building is going to be not as dense and can therefore cause some skewing in our point clouds. A couple of ways that I've had to offset this myself when we first got the scanner and we were learning the ins and outs of it were drive my car into that middle of that warehouse and then use that as an anchor point for it to latch onto something. So it's not just trying to shoot out into the distance and using the far side of that warehouse wall to kind of tie everything in together. Um, I think it scans up to 50,000 square feet in a couple of hours. But again, it varies by construction type and density. We really use these a lot, personally on our team for single family and multifamily. That's going to be where it really shines because with multifamily, this scan is really easy to kind of start out and it's a quick scan. It doesn't have it's just looks like it's handheld. It's very compact, and we're able to do multiple living spaces in one go and kind of move through each unit fairly quickly. Scanner price is around 65,000. Software is not included. They do software updates pretty frequently for this one, so it's pretty well supported. I think this is a video. Yeah. So this is an example. I said it's mostly used for smaller ones. Obviously, here's an example of a much bigger house scanned with the BLK to go, colorized point cloud. That's one advantage of the BLK to go as well. It does produce colorized images. Let me just pause right here. If you guys can see right here on the roof, there's a big black chunk here. And what that means is that we weren't able to capture that full exterior of that roof, but you could see some of that framing underneath. And what that means is generally our surveyor or technician on site went up into the attic and and because the roof was too high or some various condition made it unsafe to climb onto, they scanned the interior of the attic and that was able to gather that pitch of that ceiling and roof correctly. And the reason that it's black is because this is a color-based point cloud. There's no light at the attic, so it doesn't give us any realistic color imaging up there. Let me just go ahead and continue that video for you guys. Yeah, so right there you can see that framing in the attic space here. You can see the individual leaves and the colors of the leaves shown. And here's an example of a model of a home scanned by the Leica BLK to go. It's a 5,000 square foot single family residential located again in Washington. I think they just have a more diverse type of projects that we like to use for our showcases. The client requested floor plan, roof plan, exterior elevations, and still photos alongside this Revit model. Looks like this one took our surveyor about 4 hours to scan on site and then 29 hours to draft, and then that's not including QA. We do 2 rounds of QA after a project, so it does take a pretty significant amount of time after the scan itself to then model it accurately based on that point cloud. All right, I'm just gonna give fun facts about our guys in the pictures here. That's Taylor. He just had his first kid. So and he's already back at the office. Shame on him. He should be with his kiddo. But I'm very lucky that he is because he's part of our IT team and he's very fast in answering all my tech related problems. Here he is holding the Faro Orbis that I mentioned earlier that was previously made by GeoSlam. It's again another mobile laser scanner. As you can kind of tell the difference, this one looks like it has just a lot more stuff on it. That thing that he's wearing across his chest is the data logger, which connects to the actual scanner. It does shoot further than the BLK to go. Um, so the uses is going to be more. It's going to have more uses. Basically everything across the board. This one can handle single family
Right
from single
now?
family. I'm sorry. Oh, um, all right, I'll keep going. So it could go from single family residential buildings to, larger warehouses, because it just has that much more processing speed. Scanner price for this one runs you around 75,000 last time I checked, software not included as well. So they have different suites of software they use. If you do need to merge, I think there's like two different software bases that you need to purchase with them. Um, Here is the old, I think, Bed Bath and Beyond warehouse in San Francisco that we scanned earlier this year with the Orbis. And as you can see, this is a fairly large property that required a lot of creative scanning by our surveyors. Looks like they even cross the street here on this side. It's able to capture the parking lot up on the roof, all of the interiors scanned as well. And as you can see, the scan kind of goes off around on this side. You can see the cars here, and that's us not even walking into the parking lot and just walking along the sides of the building. Um, yeah, I remember this one pretty well. This one took our team a couple of days on site to make sure that they accurately had everything. Another example of a Revit model of a retail building scanned by the Faro Orbis. This one's a 13,000 square foot building in San Francisco. Client requested floor plan, reflected ceiling plan, along with this Revit model. It took us about 5 hours on site to scan and 23 hours to model this project.
Real quickly,
All right.
we got a question from Jared in the chat. How many hours would you expect it to take to draft a standard 2,000 square foot single story home in Revit?
2,000 single sort. Um, In terms of drafting time, it's hard to say, but in terms of production, all of our for Northern California at least, it takes us about 2 to 3 weeks, depending on how busy we are at the time of the year, to get the finished model delivered to you after the scan is completed. For something like that, I would wager closer to 2 weeks. Good question, thank you. And again, that doesn't necessarily coincide with the number of hours it takes to model that project, but from the moment that a scan is completed, we have to compile that data and then send it off to our production team, who then that data compilation takes some time. We send it off to our production team to actually model the building, and then again, our 2 rounds of QA to make sure that it's as accurate as we can get it.
Thank you,
Um,
Lee. And we got one more question in the chat from Spencer. He says, for many tight and fussier interior remodels, 10 millimeters or 3/8 of an inch accuracy is not accurate enough when splitting inches. Would you recommend falling back on manual measuring in those cases or spaces?
um, yes, I would. Based on my experience, are you an interior designer, Spencer? Based on my experience, at least, more of our local, our very local projects in the Bay Area, 1/4 inch to 1/2 inch tends to be enough for accuracy. If you do need something more accurate, it really depends. You can bust out the RTC 360, that terrestrial scanner that I was talking about, or use it in conjecture, use it with manual measurements to kind of get a basis and then dial in on specific areas. So we do interior elevations. Um, which is going to be much more higher level of detail for certain walls that might be needed. But if you need it, like if you need a wall captured within a couple of millimeters or an eighth of an inch, I would recommend going on site with a tape measure and getting those measurements, or again using the RTC 360. Hopefully that answers your question. All right, up next, talk about point clouds. Once once your scan is processed, you'll need to review the output. Were all areas covered? Are there any flaws or errors? And can we ensure that there is no drifting? Here is a scan, a pretty old scan. It's going to be a lot of what we produce is, I would say, higher depth than this now. This one, as you can see, is not color based. And then here's a more recent scan. Most scanners have a range of hundreds of feet, which can produce a lot of data outside the project that you don't need. You'll need to clip or crop your point cloud to reduce file size by getting rid of this unwanted data. So that's kind of what I was talking about, compiling that data. That data can be 10 gigs to, I've seen scans get up to I think half a terabyte. You'll have to talk with our some other team members for how big these and how dense these get, especially for a large hotel. Um, if you need to produce multiple point clouds for large or complex projects, it's going to be important to get comfortable with point cloud software that will allow you to merge or register your clouds to more easily manage your data. So this one was, I believe, the Coronado Hotel in San Diego. This one took hundreds of scans and a lot of registrations to kind of create this one usable point cloud that I believe we then brought into Revit to make a model of. Um, let's see. Processing requires all areas of data connecting one area to the other, so they could be properly glued together, merged together, registered together, all the same idea. Um, Things like mirrors, moving objects can also trick the process and therefore give you a bad output. The screenshot here is of a multi-level structure. This one is, I think, in the foundation space. And the issue that spaces like this can cause is because there are fewer unique features, um, it would be kind of viewed as an open empty space, and then it produces a challenge where if it's a repeating column or structure that in the processing phase it can then use that it doesn't recognize necessarily that each column is different from the other, and that can create a bad output. So kind of like what I mentioned, using uniquely shaped objects in there can help uh, tell the scanner what items to latch onto in the processing. So if you threw in a huge, origami piece in there, it'll use that unique feature to then link the other columns that circle that object. I mentioned point cloud drifting earlier. Drifting is a pretty common problem with mobile scanners and occurs for several different reasons. Here on that lower right-hand corner, what happens is because that distance that it shoots is not as far as like a terrestrial scanner, um, it can then use and there's not enough access points. It then creates this drift where it doesn't realize that the walls are going to be a consistent thickness. One way to offset this is to have multiple access points so that it's able to kind of tie that point cloud back together a little bit more closely. So it's important for our surveyors on site to keep an eye out for multiple types of drifting inside and outside of the building during the scanning process. Another way that you can offset this is if you did multiple scans. So one scan at the left side with some partial scans on the right, and then another scan of the right side with some partial scans on the left. And because you're not walking fully around that building, you could then register those two point clouds together for a little bit more of an accurate point cloud. And up next, is going to be drafting and modeling. Now that you've collected the data using the methods we discussed, it's time to create actual plan sets. Um, Before we move forward to section three, however, here's going to be our next poll. What software do you guys normally work in? AutoCAD, and you always plan to work in AutoCAD? AutoCAD, but you're moving into different software. That's a lot of the cases with our clients nowadays. A lot of calls from people who are formerly used AutoCAD and now are moving into Revit. Seems to be a majority of people changing. Revit, ArchiCAD, or SketchUp. Um, ArchiCAD is definitely the least produced one, least used one, I would say, out of these options. But the ArchiCAD clients that we do have are definitely diehard ArchiCAD fans. So again, if everyone could put their answers in the chat, I would appreciate it. Alrighty, next slide. Now let's dive into drafting from the point cloud. So when drafting from a point cloud, first thing you need to do is get into a drawing environment. Point clouds can be imported directly into AutoCAD or Revit, as well as other architectural software that I mentioned earlier. If you use Autodesk, you need to use an application called Autodesk Recap to prepare the point cloud to ensure it works in this entire software suite. Drafting from a point cloud in AutoCAD is mostly straightforward, but it takes getting used to because you have to work with the UCS system to kind of flip that point cloud at different viewports to make sure that you get like multiple views of that point cloud. Um, point clouds are ideal as built. Point clouds are ideal as built data sets for creating Revit models because you get that 360 point cloud that you can model from. Um, So fun facts about this building, I actually scanned this one in Seattle when we first opened our Seattle office. I guess not really a fun fact. It had a seaplane port, and I thought that was really cool when I scanned it, and it wasn't raining, so that was nice. Um, all right, so moving on, CAD drafting from the point cloud. When drafting from AutoCAD from a point cloud, you want to make sure that first of all you're setting that point cloud so it's positioned orthogonally for easier drafting and maximizing accuracy. You then want to position your cloud on the z-axis in AutoCAD as well, so that the finished floor is set at 0, and that just helps you move up and down as you take live sections to draft from. Right here is an example of a live section. It doesn't look as dense because we're only doing maybe a 10 millimeter live section crop at about waist high. So you can see the bed, you can see the couch, you can see the TV and the TV stand here and the kitchen cabinets that we're drafting from, but you don't see the ground but below, which helps the drafters kind of see what they're drafting. Um, Many scanners will not pick up smaller items, especially if they're flush with the walls or ceilings. Um, Wall registers, smaller HVAC items, uh, sprinkler heads will all need to be manually measured and added to the finished output for these types of projects. Um, so drafting other views, such as elevations from the cloud, when working in a 2D environment, it's not only important to have your point cloud oriented in the drafting space, but you'll need to be well practiced in manipulating the coordinate system that UCS I was talking about earlier in the point cloud sections. Once you do, you'll see that this is where a huge advantage of having a complete point cloud for drafting comes in. Providing you were able to have access to the roof and scanning, you'll have a complete picture of not only the roof behavior at a specific point, but also every height that you'll need to properly draft your roof from, and extra elevations and section cuts. So way at the very beginning of the presentation, I said down the road, if someone needs a bit more section information, because we have that point cloud, because you've generated that point cloud, you are able to get it. Um, As with electrical and RCP components, sometimes it's beneficial to revert to traditional methods to sketch elevations and ornamentation you like to include in your drawing just because of that higher level of detail you might need. And like someone asked earlier, if you really need something, a particular piece of ornamentation, a highly detailed fireplace, something in the living room, we recommend a mix of point cloud and hand measurements to get those smaller spaces and tighter areas locked in. All right, so now that we see how to set up the point cloud in AutoCAD for drafting, I'll show some examples of let's talk about how to set up this point cloud in Revit. Um, the level of development system, sorry, was created for the AEC community to put standards in on BIM drawings. It describes the different ways in which 3D objects can be represented existing or design elements in a BIM model with level 100, the lowest, meaning you just kind of mass the object thoroughly, and level 500, the highest, being so detailed and exact that you're essentially building a virtual version of that structure. We do everything in LOD 200, 250, or 300. The vast majority of what we do is 200. Um, LOD, we find that LOD 200 is the most applicable range since you're assessing a structure that has been built from the outside. It's not, X-ray based, so we can't tell you exactly where the framing is unless it's exposed. With many interstitial spaces being inaccessible, the specific construction of many architectural and structural elements cannot be determined, hence LOD 200 for point cloud based output, which is required for models in LOD 300 and above. So a couple of facts about this one. Some of these projects. Here's a geodesic dome that was scanned in Santa Cruz a few years back. Couple of churches. This one in the center, upper center, is in Oakland. This one in the lower left is also in Oakland, I believe. Here is a former restaurant space that they're remodeling, or a auto shop turning into a restaurant space in the upper right in Alameda, California. And I think this one down here is a DC project. Not sure exactly. Fun fact about this upper church in the middle, I always like to say is when we were scanning, there was a coffin in that basement level. And I was the one that scanned this, and I asked the guy, I'm like, hey, is there anyone in this coffin? And he kept saying, there's no one alive in this coffin. Um, and I was trying to figure out, I'm like, yeah, I mean, so is there someone not alive in this coffin? And he never told me. So I think about this project a lot. Let's move on. Modeling from the point cloud. So similar to drafting in AutoCAD, first thing you need to do to work with the point cloud in Revit is to make sure that it's in recap format to use with Autodesk products. Using the point cloud to guide modeling in 3D can be more complex than drafting in 2D. However, the benefits of having all elements of a building relating to each other in 3D can be valuable to design and planning process. So, for example, if there's a lot of RCP elements, you got duct work, you got piping for fire suppression systems, to get to show where all of those items are relative to everything else in a 3D space can make planning a lot easier. Viewing the point cloud and model in 3D provides a lot more information on how structure and the key systems and architecture interact. So here's an example of a industrial space that was scanned by the RTC 360 and then modeled in Revit. It does seem a little bit more overwhelming at first, just because there's a lot more to consider when modeling in a 3D space. But solid order of operations for creating a usable Revit model will go a long way for that digital twin or other uses that I mentioned earlier. Point cloud setup. Let's talk about modeling the plan view items from a cloud in Revit. When modeling in Revit from a point cloud, you want to ensure that the cloud is again positioned orthogonally in plan view so that you can use the ortho function to place walls. Then to set up the finished floor of your cloud as 0. and then create all the other levels to key features in the point cloud. Once you've done setting up the finished floor, you can start adjusting your view ranges and view depths in your plan views to add walls, doors, window families in the places indicated by the point cloud. One advantage that we hear from clients working in Revit versus point cloud, sorry, AutoCAD, 2D AutoCAD files is going to be you get more informations that we wouldn't necessarily show, but could show in 2D, such as door heights, and then we could set a schedule for all the windows and doors within a building. Um, Now, going from plan view into modeling vertical information, as with AutoCAD, this is where there's a huge advantage of having a complete point cloud for modeling. Drawing sections and adjusting section depth is crucial to viewing point clouds effectively when adjusting window heights, door heights, and creating roofs. Practice patience. Roofs are tough to model. But even more so when you want to accurately match a point cloud. And some examples of those are, flatter roofs where it's not even when you're standing on that roof, it's hard to determine where the pitch is. Because we have that point cloud, we can do very, very small incremental changes along the z-axis to really kind of pinpoint where the drainage systems are, where the water is going. It helps with looking for, um, you know, if someone's got a pool on their roof from rain, figure out how to work on the roof from there. So there's some advantages to having built BIM as built models, which some might not know. Sometimes a three-dimensional model is only considered for the presentation for design purposes, but it could also be useful for an as built as well. Um, it could be viewed in multiple phases, so you can easily switch between existing as built demo, proposed, and alternative proposed phases. When you have a BIM model, moving from the design phase to the construction documents phase of a project is a lot more efficient. Having an as-built BIM model can make it easier to understand a project that you haven't visited yourself, since you can cut sections, view interior spaces, and review roof massing all in 3D. Um, when I'll talk about that later, but some believe that Revit offers a more intuitive design experience and allow users to present 3D images at the planning stages to the owner or planning departments. We do get a lot of requests for things to be modeled in SketchUp, because a lot of people just find that showing SketchUp models to prospective clients, it's easier for them to kind of understand that design process. Um, and then in terms of cutting sections. When I get a quote request for a Revit model and there's a section, I usually try to convince them not to get the section, just because theoretically, if you're working in Revit, you can cut as many sections as you need without us having to really do anything. That's a pretty big advantage of having a BIM model. I think this is going to be the last poll for the day. But what is the most important factor to you when obtaining your as-built plans? Quality and accuracy, timeliness and turnaround time, general turnaround time, efficiency, and cost. If it's all of the above, please feel free to put A, B, C, and D. Um, yeah, just leave this here for a second. Oh, and we are already at Q&A. Had a couple of questions throughout the presentation, but was there any other questions from anyone else?
There were a few, Lee, that I documented. I'll
Okay.
go ahead and read them off. There's three of them that I saw, and then we can take any others afterwards. But Aaron asked, from an old dog, can the software be integrated with a drone?
Um, Yes, I'm trying to understand. Can it be integrated with a drone? We do have drone. There are drone-based LiDAR scanners. So if you're talking about using an actual drone-based LiDAR scanner, that could work. Um, we do use drones already for photography reasons. So for example, some examples I showed, we don't get full roof coverage, and we want to understand if it's a really intricate roof, we want to understand what's going on up there. All of our photos projects come with photos for the QA process, but we do use drones to go up there and take photos so that we can then use whatever information we have from ground level to work with drone photos to make sure that the final output is accurate. Does that answer your question? Hopefully that does. Okay, awesome. Um, Sorry, Alexis, did you want to read off the other questions?
Yeah, of course. So the next one from Oho, I believe it might be Ojo or Oho. Do you use control points, targets, etc. for larger spaces? And this is referring to the point cloud.
Yes, absolutely. That actually is something we're moving into as well as we work in partnership with land surveyors to make it like an all-in-one type deliverable where we can, if someone needs a land survey and an as-built, we use control points to then tie everything together. That's something that we're trying to figure out how to best show for projects. Control points really help with maximizing accuracy, and tying it in within a larger space. Um, and then to kind of further expand on that, for land survey purposes, they don't necessarily care about things being orthogonal, because they're doing it to make sure that the survey is accurate. So they're not doing it for as-built purposes. So when we previously try to tie in our models with land surveys, is the walls are always going to be a little bit skewed because if you get 10 people to measure one building, there's always going to be a little bit of discrepancies because you have to make those concessions, right? One wall might be 10 feet, one side of that wall might be 10 feet, 5 inches. So we split that difference to make walls as orthogonal as possible when possible. So that those control points help um, tie in what we do with land surveys.
Sweet. And then we got another question, two more questions from Jared. The first one is, and this is referring to scanning and point clouds. There are some situations where drift is always going to happen unless I create multiple scans. Are you able to manipulate the scan and bend it back in recap? And then bend was in quotes.
And sorry, I'm gonna scroll back and see that question just so I can make sure I can answer it correctly. When drift is always going to happen unless I create multiple scans, are you able to manipulate the scans and bend it back in recap? I believe so in recap. Um, I would not recommend doing it in recap because recap is not, in my opinion, not the best program to do it in. It doesn't give you as many functions. There are other programs to 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 bend and fix those drifting errors. There's free programs like Cloud Compare. I don't recommend that because it's a free program. It's not very supported, and if you toss too many point clouds in there, it'll just crash your computer over and over, no matter how much RAM you have installed on it. Um, when I was talking about the scanners with the software that they provide, so Faro has Faro Sphere, which is able to help align those point clouds together, which can eliminate those bends. Um, when you're essentially, so there's multi-point, if we want to get really into the nitty-gritty of it, so there's multi-point processing. So if you're processing and then you're done processing multiple point clouds and then you're trying to merge them, if it's a multi-point processing multi-slam algorithm, it can then eliminate those bends for you automatically because then it's using now two or more data sets to create a more accurate point cloud. Um, if you're not doing that, you can then manually align two clouds yourself. Um, and then once they're aligned, you can then click into individual clouds and then manually just delete the bent walls, so that when you click out of it, you get two clouds that are aligned, and then you've deleted the part of the cloud that you know is incorrect. Um, Hopefully that answers that first question.
And then the last question from Jared was, does your team, and then we have one more question after this.
Yep.
Does your team typically model everything in one software and then export?
Um, no. We generally model it into whatever software that is requested. So if it is an AutoCAD project, 2D AutoCAD project, we will just directly create the plans in AutoCAD. If it is So no, sometimes if it is in SketchUp, the deliverable is in SketchUp, we will generally model it in Revit and then do an export into SketchUp for cleanup. But we don't, if it's in Revit, if it's the output needed is 3D Revit, we'll never model it in 2D AutoCAD and then, then create a 3D Revit model from it. Doesn't make too much sense for us to do it. To kind of go further on that, if a lot of clients will want a Revit model and a 2D AutoCAD drawing from us, in which case we would model it in Revit and then do export down and then clean up and then do a 2D file delivery as an extension of the 3D Revit model. All right.
Great. And then we have another question from Anne Sum, and it looks like we've delivered two projects for Anne in the past year. So thank
Yep,
you for
recognize
using
your name.
this. She asked, do you anticipate any AI being used for or replacing drafting?
Yeah, absolutely. I don't just anticipate it. We have experimented with doing it in the past for really larger commercial spaces. Yes, I think it's good as a tool. As for replacing drafting, I don't foresee it happening in the near future. Down the road, who knows? Who's to say with AI? But it's using in that case, what we do for the few large projects that we've done with like smaller office cubicles that require just a lot of like monotonous work, AI is really good for that. What we then do is increase the amount of QA time to make sure that it's interpreting that data correctly. All right, I see a lot of questions here. So I'll just kind of go down the list, Alexis.
Go for it.
What about Faro? So Faro is going to be one. Faro makes one of the scanners that I talked about earlier, the Zeb Orbis. The Faro Orbis, it's that blue one with the GoPro looking camera up top that's connected with the shoulder strap to our model Taylor in that image. Like I said, we primarily use scanners by Faro, Leica, yeah, Faro and Leica, really, because Leica makes a heavy duty one as well as a handheld version. Does your firm deliver MEP as built? Um, to an extent. Um, so whenever I get any requests for people with MEP, I get on the phone and I go, what exactly in terms of MEP do you need? We're not an engineering firm, so we can't necessarily tell you what the different ductwork and the different MEP exposed MEP elements show. So we've done facilities for schools and labs where it's just piping and mechanical elements on the ceiling. We can model those in, but then it's really meant as a first step for whichever party that we're delivering to have their team of engineers to then go into Revit or AutoCAD and label what those MEP items are. Same goes for items within walls. Can't unless it's exposed. We really we don't know what's in there. Could you recommend any AI Revit extension to auto-generate walls, windows? Um, I'll be honest, I'm not the best person to ask. Jared, if you want to shoot me an email, I can connect you with some of our Revit guys on our team that can better answer that question. I know Shaden from our team has worked with Revit the longest. I'm pretty confident he can answer that question much better than I can. All right, I'm just gonna scroll up, see if there's any last questions. Okay. All right, cool. Unless there's any other questions, if there are, please feel free to shoot me an email, shoot our team an email, if I can't answer them. Like I couldn't with Jared's last question here, I can at least direct you to team members who can. Um, I primarily worked in AutoCAD myself. Not much. My knowledge on Revit personally is more theoretical. So I can point you in the right direction if you do have any questions. So again, thank you all for taking part. Um, and yeah, appreciate everyone's time. All right, Alexis, is there anything I need to do before we end this meeting here?
Yeah, if you don't mind sharing the last slide of the presentation one more time, that will have Lee's.
Oh, you're right. You're right. Yeah, sorry about
No,
that.
no worries, Lee. I'll also drop that into the chat in case anybody wants to shoot Lee an email or give him a call, um, so that everybody has that.
Um, you know what? Can you guys see this now? Last slide.
Yep, looks good. And then we'll also be selecting somebody for